This episode is about memory, and it's about your coding agent being able to remember things that you do and not forget it just because you had to start a new session or your computer rebooted or whatever. Uh, I think by default, a lot of these agents, they don't have much memory built in. I think they finally have given Claude a little bit of memory. It's not much though. It just can look at some of your recent sessions. It doesn't do cool things like be able to say, hey, 3 months ago I worked on this project. Can you tell me more about that project and what we did? And or as you're doing stuff, it like says, hey, you're doing this quite often. Let me put this into a longer term memory so we can recall what you do often. Or hey, I just did a new session. What's happening? So by default, a lot of these agents do not have that, and it's kind of left up to us to figure it out. So that's what this video is going to be about. I found a cool tool to do that, and I'm going to share that cool tool in this video. But first, I would love it if you go down into the description. I'm taking notes on this. There is a guide about building your own Agentic OS, your own personal coding agent harness. So we're walking through all this stuff, and it's something so you could, use OpenCode, Codex, or Claude Code and switch them and still have your same harness working with all your memories, all your skills, and everything else already in there. So that's what this guide is about. Go there, download it. It's going to have the notes from today as well on because what I'm talking about directly builds into this guide. So go down there, grab it. All right. And now let's start talking about memory. Okay, so as I said before, the coding agent you have has very limited memory. It doesn't really have a knowledge base of all the things you've learned over time. It doesn't have a recall for a lot of your past sessions. It doesn't have a good way of handling memory. It's getting there. I think, as I mentioned before, Claude Code, they've added some memory in there. I don't know about Codex. But it's kind of left to us. If we really want to have our own memory, we have to do it ourselves. This is kind of a part 2, but you don't need to worry about it. This is still a standalone episode, but this is a part 2 of previous episode where I was building out an independent memory for the Agentic OS. And it works-ish. Except that memory that I built out was it didn't hook into the system. Claude Code, for instance, has a lot of hooks. So it's like every time it does a turn in your chat, it has a hook that you can put your own stuff into and hook into that and like record memory or do something else every time that hook is called. And then it happens at the end of the session, there's a hook. And there's the beginning of a session, there's a hook. So there's all these things you can hook into and do your own custom behaviors. The thing is, Codex has its own way of doing that as well. OpenCode has its own way of doing that as well. So if you want to build a truly coding agent independent thing, you're going to be doing a lot of work figuring out how each thing works for each agent and building that in. I was going to just basically do that work and create a little translation layer between coding agents. But then I was like, wait a minute, this sounds like a problem somebody else has probably solved. And yes, they have. The solution is there. There are multiple solutions, but this is the one I saw that looks awesome. It's called agent memory. Let's dig into agent memory. First off, credit where credit's due. This is the person who created agent memory. His name is Rohit. And yeah, he's a Google developer expert on the cloud. Docker captain, ambassador. So yeah, it looks like he has a lot of good credentials. And yeah, he created this agent memory, and you see it has like 20.6 thousand stars on it, a whole bunch of forks off of this. So it's a popular repo. It is something a lot of people are adopting. And yeah, let's see what Rohit here. Thank you so much, Rohit, for creating this. Let's scroll down here to this, and this is called agent memory. And it's amazing the amount of effort that he put in here. You can even look They even put a viewer in this agent memory. So after you get all these memories for your sessions and coding agents, there even is a UI you can dig into and get into all the memories in the background. Very cool. And it's a simple npm install. It runs in the background. So it has a server that it's running in the background that has its own database. And then it just hooks into your coding agents. So if you want to like connect it to your Claude code, there's all the instructions for all these different coding agents. Yours is definitely here. All the cool benchmarks. It's like, hey, here's my agent memory compared to other systems. So like down here, it compares itself to Mem0, Letta, MMGPT, and built-in Claude stuff. And then we see some really impressive numbers on how it captures things, how it recalls things. I think there's some more numbers down here, but anyway, it does a great job of recalling, and it also does a good job of degrading memory over time. So here's the quick start. There is a part in here about how it works. Hang on. So here you go. This is basically what we would have had to build out by hand. Oops. This is something we would have had to build out by hand if we were doing it ourselves. We'd have to get all those Claude post tool hooks in there. It's doing a whole bunch of encryption to help save some of your private stuff. It's because you don't want to. Oh, also, you needs to compress things. You don't want to overload your data, your context. You need to be able to find things with a good index, see things quickly, and vector embedding, which I know a lot of the coding agents, a lot of the models use vector embedding for their memory. So it fires on the stop session end, and it fires on the start, and it loads, it tries to do a search, and it finds, you know, hey, is there something relative to this topic that you're doing? Then it tries to inject some stuff into the conversation. And here's the cool part, you know, it's like, it just picks things as it goes, everything that you do, but then it just kind of starts compressing things and asking some questions. And then it just processes your data. It takes it out of just like raw memory and capture, and then starts, you know, curating it, making it into something that's reusable. And it also decays memory over time. So if you have stuff that, you know, was just a one-off and you don't want it in your memory forever, it decays off naturally and uses whatever this Ebbinghaus curve is. And yeah, it's very cool. All the stuff is done so we don't have to do it. It's done by a really rad Google engineer, an AI engineer. So I've been using this at work with my codex setup, and it works. It had some hiccups. You have to install the tools correctly. There are some like choices you need to make when you're installing all this stuff to make sure it hooks into everything properly. And I ran into some of those issues when I was setting it up on my own. So I'm going to try it again now with my home computer. This is my home system I'm going to install this on. I'm building out my own Agentic OS. That's that guide I referred to down in the description that you can download. Yeah, if you go down to the description, you can download like how I'm building this out and do it for yourself if you so choose. Yeah, I've not done any memory system. I did a lightweight memory system where I just decoupled it and created like a kind of a short-term memory and a long-term memory database. And I just have some skills in there that Claude code kind of loads up when it starts and it knows to use the memory. But it's not a very elegant system. It depends on those skills getting triggered at the right time. So it's not hooked in like we just saw. It's not hooked in at like the start, as each turn and when the whole session ends. And it doesn't have the decay. It doesn't have like promoting things across memories into long-term memory or decaying memories out. It doesn't have any of that stuff. So having something like this that does it for you, saves you so much time. It's much more reliable than you doing it yourself and debugging and have everything go wrong on you. So I'm going to use this tool. I'm going to install it today, and we're going to use it and see it in action. Let's start installing. So I scrolled down here, on the agent memory GitHub site, and it has this big long prompt that will actually tells Claude code how to install this. So it has this big ass prompt. It's going to install an MCP as well with a whole bunch of tools and a verification step and the real-time viewer. So let me copy this and let's just install this and see what happens. Okay, here we are on Claude. Let me paste in that giant prompt from there and let it rip. Let's see what happens. Okay, so Claude did not like that copy-paste script at all. And I think it's because of some of the wonkiness I've been doing to get my harness engineering to work. On top of it, just can't do some of the stuff inside the session. Some things need to be done outside of this session. So let me do these one by one and do them by hand in a separate terminal. So instead, I'm going to go here to there, quick start, and just launch this memory. It's just a server that runs in the background, but it's not integrated into Claude Code yet. Oh, cool. Here's where it starts doing its thing. All right. This kind of feels like what I did at work, different than, okay, so you can actually see all my different, so I'm actually using Claude Code, so I will check Claude Code, but I'm also using Open Code, so I'm going to check it as well. And then, yeah, which LLM provider should agent use for compress consolidate? I really don't know. I could use Anthropic. What is this Minimax M1? No idea what BM25 mode is, but I'm going to use Anthropic for right now. I think I will change this in the future. Maybe I'll use OpenRouter, because OpenRouter can use free models. Yeah, I have Open Code installed, but that's not the same as using something like OpenRouter. I wish it would also give me Ollama. I have Ollama installed, but that's not an option. Oh well, I'll choose Anthropic for right now. Yes. Start the III engine? Sure. I don't know if that means like Roman numerals 3 engine or III engine, but yes, I will install that. Install agent memory globally, so the bare agent memory command works in any shell. Yeah, sure, why not? Oh, okay. Installed globally, agent memory stop will stop it. I don't know if this automatically starts every time. I would have to assume it would. And we got a viewer here. Yeah, this viewer, I want to see this. I might open that up in a separate, let's see here. Oh, this is cool. Yeah, this is what I was seeing at work. And so there's nothing here yet because I just installed it. But here is, you get to see the graph, all your memories, your timeline, sessions. This is very cool, be able to just see what all the memory is doing in the background. That's a nice level of transparency. And try NPX agent memory demo. Let's try the demo, why not? Oh, all right, agent memory demo. What is this going to do? I mean, it's not NPX agent memory. Started. It should be started now. Now the demo. I don't get it. What does it want me to start? All right, so there's something with my agent memory here. Let me see if I can get Claude to debug what is happening here. Of course, it works perfectly at my job, but not here when I go to do it for a demo. So let me debug it. Okay, here. Okay, so looks like we ran into a few problems here. But luckily, it seems that Claude has figured it out. Looks like there might be a bug with agent memory. It was not launching correctly from the right working directory and was not doing the right thing, but looks like there is a way to fix it. And now, once I'm in this thing, then I can run the NPX agent memory. All right, so yeah, it just has a, whoa, did that. Now, agent memory demo should work. Oh, so it did one part of the fix. Node, that didn't seem to work. Let me do exactly what it says here. I don't know, something is wrong with agent memory not installing on this Linux machine. So I am going to probably stop this demo. Ah, bummer. So I'm going down a rabbit hole now. You are welcome to join me in this rabbit hole. I started filming, and I should have tried this first on my own before filming, but now that I'm here, I want some of these extra features from agent memory that I don't have with my memory system that's already in place. So I'm going to get Claude to go through it. Feel free to drop off this video at this point because it's just going to be me messing around. I've gotten this far, so I'm going to go through it. That's how I'm going to go. So I ran this through, and I have... So right now, Claude Code is comparing against the GitHub agent memory with the current memory system I've already set up that you can see in this previous episode. And what Claude is telling me is that we can close that gap on our own without installing agent memory. That's what it tells me. It's told me optimistic things before in the past. So I'm going to go through and read some of this and see if there's anything interesting. So what gaps do I have in my current implementation? Hook routing. All right, so one of the things that we're missing are some of the hooks. And that is a session start hook. And then there's a pre-compact thing. So when memory gets compacted, we need to be able to re-inject certain things into it. That's saying that that's an extra small. And that's small, approximately half a day. Half a day in AI time is probably like a few minutes. These efforts are never accurate. And AIOS capture.sh. I think that's host tool user prompt submit. So it's just capturing as it goes. So this is some of the stuff that we're missing. Gap 2, short to long promotion. We have no current life cycle for that. And what does it propose? We got the working buffer. That is this AIOS capture.sh. Consolidate at the session end or a nightly cron. Okay. Takes the local LLM, reads the working buffer plus the transcript and extracts candidate durable facts into my permanent long-term memory. Promotion decay scoring. Oh, okay. So that's where memory starts going out of. Okay. Effort approximately 1 day. Gap 3, semantic recall. So we're using grep now, which is not the best way of doing things. All right, I'm going to build this bad boy out. This might be a throwaway video that was supposed to be about agent memory, but now I'm just kind of re-implementing agent memory based on for my Fedora system. Seriously, just go install agent memory and have it work for you. And then go see my next video. All right, let's do this. I'm going to start doing this. I'm just going to put a goal in. I'm going to make this a goal. I want it to just freaking do it all. I don't want to keep hitting this all night long. I'm just going to put this as a goal, and I'm going to come back, and hopefully it's all implemented. So I'm going to tell it. So wait a minute, what is P1? All right. Phase P1, enforcement. Phase P2, recall. And P3 is the lifecycle, promotion engine. The hard, novel part. Promoting stuff from short-term memory into long-term memory. I bet you we can get this all done tonight. But let's start with P1. Goal. Spec P1. Implement it. Test it. Verify it works. Make sure we... Actually, I'm going to put this up here. Spec P1. All right, when it does stuff like this, all right, before I'm going to jump into this, I'm going to ask it one more thing. Because I have gone down these roads before where a simple internet search would have solved quite a few things. All right, before we jump into specs. All right, so before we jump into specs and implementation, please do some deep research on this to make sure we're not overcomplicating things, or we could use a tool that could do this for us. Make sure we're doing the right thing. with memory with, see if it does that. I don't know. What I'm finding, I'm hitting this a lot in my coding and trying to get things working, is that AI will insist it knows the answer. However, it confidently tells you it knows the answer, but it didn't do any research to find out that it didn't know the answer. It didn't go to the internet. It didn't check primary sources at all. It's just telling you something, and then it's like, oh, I didn't check. Once you ask it, it says, oh, I didn't check, so ask it. It's like, how do you know this is true? Tell me your sources. Where did you read this from? As soon as you do that, that's when it says, oh, I didn't do it. So I'm noticing this a lot. I don't know how to fix it, but when I start running into problems like this, where I get that feeling we're going into the weeds and that somebody else has already solved this problem. This is basically the premise of the video, is agent memory solves this problem. But that aside, try to get it to do a deeper web search. All right, back to see what it finds. All right, so I got it to do that internet deep dive, and it looks like it found some stuff. What did it find? Yes, we were overcomplicating it. My gut instinct. The platform now does part of this natively, and I'm already using it. Oh, so Claude Code shipped with auto memory, and it writes its own learnings to memory.md. It's partly free. So the problem is that I'm building for open code as well. First party memory tool. Okay. Embedding recall is over engineering at your scale by 10x. Your corpus is 36 nodes. The whole thing fits in one context window. At that site, it isn't a filtering problem. Well, yeah, I don't have that many notes yet because I'm just building the system out, but I want it to adapt. I don't know. All right, so it says don't even bother with this embedding recall now. 3, no off-the-shelf tool fits cleanly. The heavy frameworks are all overkill. They trade away plain text legibility for scale you don't have. All right, so the right size conclusion. So solving problems I don't have. Now strip to what's real. Pre-contact and re-inject. Keep. Gap 3. Drop this entirely. We're just too early for these things, is what it's saying. It doesn't say they're wrong, it's just saying we're too early. We don't have enough data. I'm gonna put this into plan mode so it doesn't start auto implementing. Oh, you can't put it in plan mode when it's asking you a question. Damn it. Okay, so thin enforcement hook only. Yeah, I want to do the thin enforcement hook. I will choose that. I'm gonna stop it right here though. I just used open code yesterday and I loved it. Well, what we are implementing for memory work on both open code and Claude code. Or if it works on Claude code, can I later adapt it to work on open code? So I can switch back and forth between those two. Okay, here we go. It has checked to see if all this stuff will work with open code. It said, I saw it when I went through all of this stuff. Oh, it came with a plan. All right, the direct answer to my question. What we're building works on both open code session start load, works on both, and open code's session start load is actually free, and the only vendor difference is the trigger. And put the logic in one script, making the adapter a thin layer, not a rewrite. Oh, cool. So this, whatever I'm doing here, will work with both open code and Claude code. Let me read through the plan really quick. All right, our V1 is going to work for Claude code first, and then we're going to adapt it to open code later, but it should be a very thin adapter. And the V1 of this it's going to be the auto memory, but it's going to survive compaction. So whenever you compact memory, then we'll be able to still inject our context that we want. We're going to add a session start hook that runs our code here. It's going to add some guards. It's going to do a whole bunch of other stuff. I have no idea what it's doing here. All right, so the settings.json already has all the pre-to, post-to, compact. This is more entry alongside them. Cool. All right, so open code comes later. Compaction, reinjection, capture. I'm going to do a bunch of verification. I love verification, being QA. Please verify. So it's going to do some stuff in isolation. It's going to verify the hooks. It's going to do some compaction. Make sure there is no double loading of things. It's going to try to make sure open code is still compatible. I'm not going to worry about that as much for this run right here, but when I use open code, I'm sure it'll be pretty quick to just do the adaptation inside of open code itself. All right, and cleanup. And that'll be getting rid of all the agent memory stuff. Maybe I should do that first. I should probably do that first. Get rid of the agent memory and then do it. So a lot of that stuff seemed really cool says it's just out of scope for right now. I don't know if I 100% agree with the out of scope thing, since I'm pretty sure this is going to blow up quickly with all the stuff I'm doing, but that's okay. I'll revisit it. That's one thing I want to add in here is how do we revisit this? For the out of scope items, when will we know we need them? Will there be some type of warning or something that will pop up to tell us? How will we know it's time to work on these extra features? Extra memory features. Okay, I just asked it. It's like, okay, how do we know when we need to add these extra features to have memory decay, memory promotion, all this extra good stuff? And it's like, hey, actually nothing will warn you that you need to start using it. So this was saying, hey, we're going to just tie this check into the session start of the script. It'll do a quick hunt for to see if we need it or not, and it'll pop out a little warning if we do actually need it. So as soon as I open up a session, it'll give me a warning that I need to implement more for this memory feature. I just don't need it right now, but when I do, this will say something. Perfect. That's what I wanted. So here are the deferred features. And here are some statistics in order to hit those features. 150 counts greater than 500. I'm sure I'll get through that pretty quickly. And this, all right. And oh yeah, are we missing facts? Okay. All right, so it's adding this stuff into the plan to get that little tripwire. Cool. Ready to code? You know what? Yes, at this point, I think ready to code. Oh, it has all the data in there in the plan. Let's implement this. This is our minimal version of agent memory, I guess. What is this? Project loading. Aha. Okay, so through building this, found a bug in our current implementation that we should only be adding active notes. But right now we're adding all notes and blowing our budget. We're going over our token budget and context budget. So what it's proposing here is add a status marker. And the status marker in memory should say what's active and what's not active. So something we built in a previous session and shipped it shouldn't be loaded into the current context. So yes, add a status marker. Definitely. Oh man, I feel like I'm over-engineering this. Why are all the other YouTube videos really easy and then I go to do it, it just all falls to shit? It's either I'm doing something wrong or they're not telling you something. One of the two, I think it's somewhere in between. Okay, looks like everything finished here. Let's see what was built. What was built? Okay, so we have a script that injects stuff into the context. We have some more hooks in Claude for session start to re-inject on compaction. And we fixed that little active archive thing so we are properly grabbing the right memories. Cleaned up some of that old stuff from, and I totally forgot to clean up the agent memory stuff. And that decision we made to not show the inactive things has now lowered our memory just below the little trigger threshold here. It's not memory, it is our what we've loaded into context, the limitation we've given ourselves. So it verified a lot of the stuff. Stuff I need to verify. Fresh session, start a new Claude Code session, confirm I reference a known fact. E.g., your concise answers preference. I don't know what that means, but I'll have it ask me some questions, and then I'll start a new session, and then we'll see this. So, and then compaction, survival. Okay, so what I'm going to do is do these manual verifications that it called out right here, step 2 and step 3. So fresh session. Right now I'm going to have it ask me a couple questions, and then in a fresh session, I'm going to confirm that it saved that information from a previous session. Ask me a few questions. Actually, ask me 3 questions about my preferences that you don't already know. And I'm not going to tell it to save or do anything like that. So this is just saving should happen in the background. What is it doing? It's asked me some different stuff about the implementation. So I don't think it understands my question. All right, you asked me to manually verify for step 2 in a new session. Right now, I'm asking you to ask me a couple of questions so we can verify that new session retained them. That's why I was asking, ask me 3 questions about my preferences that you don't know. Let's see if that gets it right here. Okay, my preferences. Once branch PR workflow. I'll just answer these really quick. I prefer having a comprehensive CI/CD pipeline, so I don't need to review the code. I can trust the tests that occurred in the pipeline. In addition, I would love it if we had Copilot hooked up in GitHub to do code reviews, and Claude Code has to address those review comments before things can get merged. Otherwise, I want the CI/CD system to merge for me once all tests are green. That's number 1. Number 2, test discipline. Yes. Write tests by default. I'm not sure about TDD. I've heard good things, but I'm not sure if it results in a better quality process. I think make the decision as we go, whether we should adopt TDD or not. Working hours notification etiquette. Let's see, since I don't have notifications set up on my phone, anytime is fine. But if you are, we'll revisit this if we do hook you up to something like Telegram. Okay, I just recorded my 3 preferences that it asked me about. Honestly, that was also kind of cool too, because I just gave it more information about how I like to code. So that's probably something I should set up with this. Really, like, how do I like to code? How do I like to have my code verified? I think those are better questions than some of these other videos I see where they ask you like kind of all these weird random questions for it to build a profile of you. But I think that right there felt a little bit more specific to how I work. Maybe I'll ask questions like that again in the future. I kind of like those. Something felt right there. All right, so it is definitely writing all the memories down here. I'm seeing everything getting written. Okay, I think I had my microphone turned off the whole time. But anyways, over here, it had everything implemented. It just needs me to verify a few things, and I went through and I answered a few questions. Yeah, now that it wrote these notes to memory, it's now seeing if it can recall it in a new session. So I went over here to the new session, I asked those questions, and it recalled them. And what I'm doing right now, yeah, so it asked hey, do you write tests by default? Yes. And it does the TD as per task judgment for TDD. Over here, it knew our preferences that we answered in the previous session. And now we're testing that doing compact actually re-injects that. So it just finished compacting the context. Now we got to see if those exact same questions get the same answers. What's my preferred merge review workflow was the other. So let's see if it still answers this. CI/CD is the quality gate. Green equals safe to ship. Yeah. Auto merges on green. GitHub Copilot reviews. I still self-review before pushing. Is that true? The Google 8-dimension code review skill. What is that? Anyway, I answered that one. Let's do the, do you write test by default? What about TDD? Yes, by default, TDD is per task. So it remembered everything even after the compaction. Let me go and tell them. I say steps 2 and 3 worked in a new, fresh session. We got it done. What did we do? All right, we got thin enforcement, hook is complete and verified. So I was started off very ambitious, but we got this broken down to a minimal thing. So we've improved the memory from that last video that we did. And sorry for all of you that followed along with this. This just went off the rails and not where I planned on it going. But that's the way it goes with this stuff. It's all new types of things, so things go off the rails. But yeah, I got the session start hook. I got this stuff with compaction. So I really cleaned up a lot of the stuff to make sure it's always getting every single thing. So it is now better than where it was. It used agent memory as a, I'm going to switch over to cam here. It used agent memory as the, as a point of reference. It's like, oh, this is what you're trying to accomplish. The thing is, it actually did a lot in the background that I didn't even know about when I was designing the other memory system. With the short-term memory going into the long-term memory, actually did a lot with hooking up into Claude code. And I didn't realize how much was already done. But this went the extra step of getting all the hooks in there, surviving compaction, being able to do all of that stuff. And the best thing is the little tripwire thing. So once we start doing too much with memory and it becomes inefficient, this tripwire comes out and says, hey, you need to do something. And that'll lead us to our next steps. Because it didn't want us to code for problems that we do not have yet. I was trying to figure out how to promote memories, how to, it was promotion memories, how to decay memories, and it's like you don't have enough memories yet for us to know if any of the solutions we give it will actually work or not. Fair. Don't over-engineer. Wait till you actually have the problem before you try to solve it. Lesson relearned. But that's it. I got it set up. We tested it out. We just saw that it remembers things from session to session. And yeah, I will be playing with this over and over again. I don't know if this is going to help you at all, but I'm going to update what I did in this session and get that into the Agentic OS build document that I am working out now. It'll be in the description notes. You can download it. And as I keep building out this Agentic OS, you will get updated documents. So you will be able to build this for yourself, and it should work regardless if you're using Claude Code, Codex, Open Code. I think it even supports OpenClaw and Hermes, a whole bunch of different coding agents. The Hermes and OpenClaw aren't coding agents, but it will still work with them. Yeah, I don't know. It's really late. This took way longer than I thought it was going to take. I thought I was just going to install agent memory and be done. No. Oh, my life. Well, this video is going to be a mess. I hope you enjoyed this hot mess. Thank you for sticking around. Definitely go down there, download that guide, please. And yeah, watch this next video right here. If you pair what you've learned in this video with what's coming up next, right down here, click on it. Or right here, here. I don't know where it's going to be, but this next video, click on it, watch it. It's going to help you freaking explode your understanding of AI and test engineering. But seriously, thank you for watching. Happy testing. Cheers.